This video is about critical numbers or critical points. Critical numbers are an important component of a function. Some functions have critical numbers, some functions don't. But when you have functions that have critical numbers, those numbers can be used to figure out where the function has the highest possible value or lowest possible value, and that can be useful information. So for instance, let's say that you have a function that describes the temperature at a point, and you want to know which point has the highest temperature and which point has the lowest temperature. If you can find the critical numbers of the function that tells you the temperature, that, it turns out, can be used to figure out the highest and lowest temperatures. So we're going to talk about critical numbers, and then in a future video, we're going to talk about how those can be used to figure out the maxima and minima of a function. So let's first make it clear what a critical number even is. So let's say that you have a function f, okay? A critical number of f is a number C in the domain of the function. So it has to be in the domain of the function such that either f prime of C is 0. So it could be a number where when you plug it into f prime, not f, but f prime, okay, you get 0. So f prime of C is 0. Or f prime of C does not exist. So the critical numbers are what you get when you look at f prime. You figure out which values make f prime equal to 0, and which numbers make f prime not exist. And then those numbers, as long as they're in the domain of the function, those are called the critical numbers. So let's look at some examples. Find the critical numbers of f of x equals x squared minus 3x. So to do this, we have to look at f prime. So we know what f of x is. What's f prime of x? 2x minus 3, right? Now we want to see where f prime of x, where that's 0 or where it doesn't exist. So is there any x that makes 2x minus 3 not exist? No, right? We don't have an x that makes 2x minus 3 not exist. So 2x minus 3 exists no matter what x is, but let's see if 2x minus 3 can equal 0. So we would set f prime of x equal to 0, 2x minus 3 equals 0, and what do we do to get x? We should add 3, so 2x is equal to 3, and then what's the next thing we do? We divide both sides by 2. And if you divide both sides by 2, you get x is 3 over 2. So when x is 3 over 2, f prime of x is 0. The question is, we want to make sure that we answer this question, is x equals 3 over 2 in the domain of f? And to answer that, we have to look at our original function and pay attention to what it is exactly. So in this case, it's x squared minus 3x. Is x equals 3 over 2 in the domain? Yes, right? You can plug it in. There's no issue with plugging it into f. So x equals 3 over 2 is the critical point. There's only one critical point in this case. and it's 3 over 2. Critical number, I mean. Okay, sometimes different books will call it a critical point, but in the book that we're using, it's called a critical number. Okay, what about if you had f of x equals x to the 1/3 power. Okay. Then what's f prime of x? It's 1/3 times x to the negative 2/3 power. Now we need to see where this function is 0 and where this function is undefined. So first of all, let's set this equal to 0. And see what you get. Do you see what we can do to solve for x here? To get an idea, it might be a good idea to rewrite this expression. So I see x raised to a negative power. So when x is raised to a negative power, how can I rewrite this so that I don't get a negative exponent? When I'm raising to the negative power, it means take the reciprocal, right? X to the negative 2/3 is the same as 1 over x to the 2/3 power. So I get this, so I get 1/3 times 1 over x to the 2/3 is equal to 0. Now, does that suggest what we can do? We can multiply both sides by x to the 2/3 power. So I'm going to multiply x to the 2/3 power to get rid of the x in the denominator. So if I do that, I get what on the left? I get 1/3 because this x to the 2/3 divided by x to the 2/3 is 1. So I get 1/3 equals 0 times x to the 2/3. Well, that's equal to what? 0. So I get 1/3 equal to 0. Well, 1/3 is not equal to 0, right? So what does that mean? That means that this equation has no solution. So there's no x that makes that equal to 0. What about, so what's the other possibility? For a critical point, we want a point where f prime is 0 or what? What's the other possibility? F prime does not exist. So let's see, are there any values of x where f prime does not exist? So remember, f prime of x we can write as 1/3 times 1 over x to the 2/3. Can you see which value of x will make this undefined? 0. Because if x is 0, then you get 0 in the denominator. And the function is undefined when 0 is in the denominator. So f prime of x is undefined when x is 0. So does that mean that x equals 0 is a critical point? There's one thing we need to check. What do we need to check? We need to check that x equals 0 is in the domain of the function. Because if it wasn't, then it would not be a critical point. Remember, a critical number. Remember, a critical number has to be in the domain of your function. So is 0 in the domain of this function? What do you think? Yes, it is. Right? There's no issue with plugging in x equals 0. So this is in the domain of the function. So f prime of x is undefined when x equals 0. Let's write comma and x equals 0 is in the domain of f. So 0 is a critical number of f. And there are no other critical numbers. Let's change this a little bit. Let's say that we had something like f of x equals x to the negative 1/3. So instead of x to the positive 1/3, we have x to the negative 1/3. That's our f. And we're trying to find the critical numbers of this function. So again, we want to start with the derivative, f prime. And what's that? That's negative 1/3 times x to the negative. Well, you subtract 1 from the exponent, right? So if you do negative 1/3 minus 1, how do I do that? I need to get the common denominator because I want to write 1 as a fraction. So 1 is the same as, I'm going to write as 3 over 3, so I can get the common denominator of 3, and that'll give me negative 4/3 because I get negative 1 minus 3 on the top. So this is x to the negative 4/3. And now I want to see where this guy is 0 and then where it's undefined. So let's see where this is 0. So I set f prime of x equal to 0. And now what can I do? I can multiply by x to the 4/3 on both sides. And when I do that, so let's just write that out. Multiply both sides by x to the 4/3. And what do I get on the left? Negative 1/3, and on the right I get 0. So what does that tell me? That tells me that f prime of x equals 0 has no solutions. Oops. This equation, f prime of x equals 0, has no solutions. Let me erase this part, just so I have room. Now we need to set f prime of x, we need to see where this is undefined, right? So let's write f prime of x. Again, I can write it as times 1 over x to the 4/3. And when I do that, I can see where this function's undefined. Where is it undefined? At x equals 0, right? By the way, you didn't have to write this. I mean, I rewrote it like this, but I prefer to write it like this because it makes it easier to see that this function's undefined at 0. So you might not be sure, is this undefined at 0 or not, or can you plug in 0, right? Once you write x to the minus 4/3 as this, then you can see that this is actually undefined at 0. So f prime is undefined at x equals 0. Does that mean it's a critical point? What do we have to check? We have to check whether x equals 0 is in the domain of our function. So we have to look at our function and see what it is. Okay? In this case, our function is x to the minus 1/3. Is 0 in the domain of this function? Well, the answer is no, because I can think of this as, how can I rewrite this? I have a negative exponent, so how can I rewrite this as a reciprocal? It's the reciprocal of x to the 1/3. So f is undefined. F is the original function at x equals 0 because I get 0 in the denominator. So what does that mean about my critical point? Is 0 a critical point? A critical number, I mean? No, because a critical number has to be in the domain of the function, and 0 is not in the domain of our function. So when you look at everything we've done, what does that tell you about the critical numbers of the function? The question is, what are the critical numbers of the function? So what's the answer? There are no critical numbers. So f has no critical numbers. Because we saw that when we found f prime, when we set it equal to 0, we got no solutions, okay? And then when we saw where f prime was undefined at x equals 0, but that wasn't in the domain of the function. So that doesn't count either. So there's no critical numbers. Okay, let's look at an example where there's more algebra involved. But I want to make sure that we go over these examples first because these involve negative exponents, and I wanted to show you how you can work with negative exponents, right? By writing it as 1 over x to some power and then thinking about it like that. So here's another example. Find the critical numbers of the function f of x equals x cubed plus 9x squared minus 48x. So what's the first step? We want to find f prime. So take a moment. What's f prime of x? It's 3x squared plus 18x minus 48. Let's just make sure we understand how we did that. So the derivative of x cubed is 3x squared because you bring the 3 down and then you take away 1 from the 3 and that gives you 3x squared. For the 9x squared, you bring the 2 down. That's 9 times 2 in front is 18. And then the power of x becomes just 1, so it's just 18x. And then the derivative of negative 48x is negative 48. Okay, so now we set this equal to 0 and solve for x. So I see this 3x squared plus 18x minus 48 is 0. What's one way we can start? I mean, there's lots of things we can do here. But I notice these numbers, these coefficients, do they have any factors in common? Yes, they have a factor of 3 in common. So let's factor out the 3. And then we're going to get what? X squared plus 6x minus, what's 48 divided by 3? 16 equals 0. Okay. So now what can I do? I can divide both sides by 3. So if I divide both sides by 3, I get x squared plus 6x minus 16 equals 0. Now at this point, if you know how to factor this, you can factor this. If you know the quadratic formula, you can use that, but if you can factor it, it's going to be faster. So can you factor this? It factors as x plus 8 times x minus 2 equals 0. And now once you have this, what do? I have a product, right? I have this x plus 8 times x minus 2 is 0. When you have two things, my first thing is x plus 8, my second thing is x minus 2. When you multiply them, multiply two numbers, and you get 0, what does that tell me about the numbers? One of them has to be 0. So I set each of them equal to 0 and then solve for x. So I get x plus 8 equals 0, I have to solve that, and then x minus 2 is 0. So for x plus 8 equals 0, what do? I subtract 8 from both sides, and I get x is equal to negative 8. So I get negative 8. And then for the next one, what do? X minus 2 equals 0. I add 2 to both sides, and I get x is equal to 2. So these numbers make f prime equal to 0. And are these in the domain of my function? Yes. What about the values that make f prime undefined? Well, f prime is defined everywhere, right? I get this. This is defined everywhere. I don't have any asymptotes or anything like that. So I don't have any critical numbers that you get by making f prime undefined. So I just have these two critical numbers. And that's the answer. Okay. So I'm just going to write this out just so that you have a complete explanation. So these are in the domain of the function f. Also, f prime of x is defined everywhere. Okay, so I don't have any critical numbers that you get by seeing where f prime is undefined. So x equals negative 8 and 2 are the only critical numbers of f. Okay. By the way, you know, it doesn't have to be x equals negative 8 or x equals 2. You can just say that the numbers are negative 8 and 2. Okay. Okay. There's one that's a bit more complicated. Let's just do one more. What are the critical numbers of g of y equals y minus 1 over y squared minus 3y plus 3? Okay, take a moment, take a few minutes, maybe 5 minutes, and try to solve it yourself, and then we'll check answers. Okay, let's go over the answer. So I'm going to take the derivative, and to do that, I'm going to use the quotient rule because I have a quotient. So I take the bottom, right? That's y squared minus 3y plus 3, and then multiply by the derivative of the numerator, and that's going to be 1. And then I subtract minus the top times the derivative of the bottom, and that's going to be 2y minus 3. Now notice that I have parentheses at this point because I'm multiplying y minus 1 by 2y minus 3. Okay, so I have that, and then all over the bottom squared. Now let's simplify. I have to simplify the top. Let's not simplify the bottom because it's already factored out. In the top, I get y squared minus 3y plus 3. And then I have, so let's talk about how to simplify this. So I have a minus, okay, minus this whole thing, right? I'm subtracting this product. So first I want to figure out what that product is. So I need parentheses after the minus sign because I'm going to subtract a bunch of terms being added up. And when I do that, I need a parentheses right after the negative sign. So when I distribute the y minus 1 times 2y minus 3, I get 2y squared. Okay, that's from doing this. And then minus 3y. And then minus 2y. And then negative 1 times negative 3 is plus 3. So I get this over the bottom. And now I still need to distribute the negative sign across here. And then simplify. So I'm going to get y squared minus 3y plus 3. And then minus 2y squared. And then what? Plus 3y, because I have a negative times a negative, right? I have this negative here and this negative here. When I have negative 3y, that's positive 3y. And then I have negative 1 times negative 2y, that's positive 2y. And then a negative 3. So this all over y squared minus 3y plus 3 in parentheses squared. Now I need to combine the like terms in the numerator. So I look at the y squared terms. I see a y squared here and a negative 2y squared there. And that's it. So y squared minus 2y squared makes negative y squared. Now I look for the terms with the y's. So I get negative 3y. Let's make sure there's a negative 3 there. Negative 3y plus 3y plus 2y makes 2y. And now we have the constant terms. I see a 3 and minus 3 makes 0. So you just have negative y squared plus 2y on the top, and then the bottom is just the same throughout. Okay, so that's my g prime of y. Now I set this equal to 0 and solve. First, let's figure out where g prime of y is 0. So that's when negative y squared plus 2y over the bottom and yes, I'm writing out the bottom all the way through, so where this is 0. What can I do to solve for y? I can multiply both sides by the denominator. And if you multiply both sides by the denominator, you're going to get negative y squared plus 2y equals 0 times the denominator. And what's 0 times the denominator? 0. Okay. And now what can I do? I can multiply both sides by negative 1, so I'm going to get y squared minus 2y equals 0. It's always a good idea when you have a quadratic to make sure that the coefficient of y squared is positive. It just makes it a little easier to factor. So in this case, we can factor this as y times y minus 2 equals 0. We set each of those equal to 0, right? So we get y equals 0. And then when y minus 2 is 0, we get y equals 2. So I get 0 and 2. Now I need to check if those are in the domain of my function, so don't forget to do that. So are 0 and 2 in the domain of this function? Actually, you only need to check if the denominator is 0. So if you plug in 0 or 2, do you get 0 on the bottom? No. So these are in the domain of the function. These are in the domain of g, so 0 and 2 are critical numbers. Now we need to see where g prime is undefined. So g prime of y is this. So where is this going to be undefined? What do I need to do when I have a function divided by another function? I have a numerator and a denominator, and I want to see where this function is undefined. First of all, are there any issues with the numerator being undefined? No, the numerator is always defined, right? So the only issue is when the denominator is 0. So this is undefined when the bottom, y squared minus 3y plus 3 squared is equal to 0. And when you have something squared is equal to 0, the thing inside is 0. So it's y squared minus 3y plus 3 is equal to 0. And I need to figure out where those are. So what happens if how can I tell without using the quadratic formula if this quadratic equation has any solutions? I can look at something called the discriminant, right? It's b squared minus 4ac. And when I do b squared minus 4ac, so when I look at the discriminant, b squared minus 4ac is negative 3 in parentheses squared minus 4 times 1 times 3. And what's that equal to? Negative 3. So the discriminant is negative. When the quadratic has a negative discriminant, what does that mean? It means that it has that this equation has no solutions, right? It has no real solutions. When this quadratic is equal to 0, that equation has no solutions when the discriminant of this quadratic is negative. So since the discriminant is negative, y squared minus 3y plus 3 equals 0 has no real solutions. Okay, so 0 and 2 are the only critical numbers of the function. So that's the answer. So let's just summarize what we did, just to make sure we understand the general concept. I mean, this was a kind of long question, but the idea was, once you have this g, we find where g prime of y, we find what g prime of y is first. Then we set it equal to 0 and solve for y, and then check that those are in the domain of the function. If they weren't in the domain of the function, we would throw those numbers out. Those wouldn't be critical numbers. Okay. Then we see where g prime is undefined, and in this case, it was when the denominator is equal to 0. And in this case, the denominator is actually never equal to 0 because the discriminant was negative. Now, if the discriminant was positive, okay, it wasn't in this example, but if you had an example where the discriminant was positive, then that tells you that this equation is going to have roots. There's going to be y values that make this equation true. And then your function would be undefined there. Okay, and then you would have to check for those points if those numbers are in the domain of the function, of the original function. If they're in the domain of the original function, then they're critical numbers. If they're, and you would have to include those, in your list of critical numbers. If those numbers where g prime of y is undefined, but g is also undefined, okay, those would not be critical numbers, and then we don't include those. Okay, that's what I wanted to say in this video. Thanks.